Hello and welcome to this first video about LaTeX. Today we are going to cover the basics of writing a document with this very powerful typesetting system. So, to start, what is LaTeX? It turns out that to answer this question, we must actually answer another one first. And the question is, what is TeX? So, TeX is a markup language, kind of like HTML or XHTML. TeX is also a programming language, and TeX was invented by one of the most important figures in the history of computer science, namely Donald Knuth, around 1977. And here in the picture you can see a very young Donald Knuth working on an IBM 650. Now, why did Donald Knuth invent TeX? Well, he was really not very happy with the situation of the typesetting industry. Scientists did not have the tools to typeset documents themselves, and they had to rely on external resources. Unfortunately, TeX has one big problem. It is very hard to learn. This is all very nice, you might say. But why should I care? Well, if you have ever had anything to do with Microsoft Word or LibreOffice or any other similar program, you will be well aware of the kind of problems that one can run into when trying to make things look as they should. So, let us ask ourselves again this question. What is LaTeX? Well, as far as I know, LaTeX stands for Lamport Tex. And LaTeX is nothing but a series of macros to make TeX easier, and especially when it comes to mathematical formulae. LaTeX was written by Leslie Lamport, another very prominent figure in the computer science academia. LaTeX is so structured as to allow the author to focus on the content and not on looks, and it follows the what you see is what you mean paradigm, as opposed to what you see is what you get, which is very common in word processors. One very interesting feature of LaTeX is that it takes plain ASCII files as input, although UTF-8 files are also viable via additional packages or a different compiler called KTeX. And these text files contain the body of the document, the text that should appear in the document, and some markup. The output is generated by a compiler, and it can be in either DVI or PDF format. One problem that LaTeX compilers have is that errors may be cryptic, to say the least. If you are interested in getting LaTeX up and running on your computer, you should be aware that, like Linux and BSD, LaTeX comes in different flavors called distributions. There are distributions for all the common operating systems, and in particular, the most famous are TeXLive, which is a cross-platform distribution, MikTeX, which was born as a Windows-only distribution but now is available for Linux in beta, and MacTeX, which is a macOS-only distribution. While one can use a general-purpose text editor to work with LaTeX, there are a lot of other editors and environments that allow a better experience. Here are the most common. The first one is TeXmaker, which is a cross-platform editor written in Qt, and it allows quick access to the document structure. It also has access to code snippets and the different compilers, and it also has an embedded document viewer. There is also TeXworks, which again is a cross-platform product, which is a very simple editor and viewer with not much automation available, but it is scriptable. Then we have the couple Kyle and Ocular, which is part of the KDE suite. Kyle is a very powerful editor and Ocular a very powerful document viewer. Technic Center is similar to TechMaker and Kyle, but it is Windows only. And then we have ScriptTech, which is an online service for collaborative LaTeX editing. There are also other programs that one could use, such as Text Studio, VI, Emacs, or other text editors. So let's get down to business and write our first LaTeX document. Here it is. You can see that we have a part which is called a preamble, and then a part called a document. If we input this file and compile it, this is what we get. There, we have just seen how to use LaTeX from the command line with well-known editors in both Windows and Linux. And now it's time to introduce the most important part of LaTeX, which is LaTeX commands. LaTeX commands all have the following form: \, the command name, then options in between square brackets, and then up to 9 arguments in between curly braces. The options, as you might imagine, may be omitted, or we might just put some empty braces. Also, depending on the command, there may not be need for options at all. Furthermore, not all commands require arguments. LaTeX commands start with a percentage sign, and everything that follows until the end of a line is part of the command itself. As you might remember, the first command that we used is the document class command. Document classes are tech or LaTeX scripts that prepare the layout of a document according to typographical rules and also provide usually additional comments to be used. The class of a document is absolutely required, and it can be selected with the command \document class and the usual options and the class name. Options include things such as character size, paper format, whether the document should be double-sided or have a 2-column layout. The document class command must be in the preamble, and it is usually the first one in a document. Some of the most frequently used classes include the following: letter, for writing letters; article, which is used for scientific articles, short reports, and similar documents that require no chapters; IEEE transactions, which is a specific class for the IEEE transaction journals; proc, which is a class based on article and is used for conference proceedings; report, which can be used for longer tech reports or small books and anything that includes chapters; book, whose goal is to help typeset real books with parts, chapters, and everything; memoir, which is a very customizable class for books and theses; slides, which was used in the past for transparency slides and typesets everything using a sans serif font, and Beamer, which is a class for beam projector slides, again highly customizable. It is important to know that journals and conferences usually provide custom LaTeX classes that you can download and use in your document. Also, some of the most common document class options include the size of the main font, which is set to 10 points by default, the size of the paper stock, which is letter paper by default on most distribution, flush left equations, which means that all equations are aligned to the left instead of centered in the page, left equation numbers, to obtain equation numbers on the left of the equation instead of the right, title page or no title page, which decide whether there should be a separate title page or not. Some classes like book have a separate title page, whereas other classes such as article have no dedicated title page. One column or two column, which are fairly self-explanatory, as are two side and one side. Then we have open right and open any, which are used to decide whether chapters should be started only on right-hand pages or also on left-hand pages. Landscape, which outputs a landscape document, and draft, which is very useful during the review phase of a document, as it marks typesetting errors with a small square on the right-hand margin, and it also does not output graphic files for a faster rendering. Another very important factor in LaTeX is environments. In our small test document, we have already used one of these. In particular, it was the document environment. All LaTeX environments are marked by two commands: \begin and then the environment name as an argument, and \end and the environment name as an argument. Anything in between \begin and \end is part of the environment itself. For every \begin, there must necessarily be a corresponding \end. Also, environments can be nested. The document environment is a very particular one, as it marks the beginning and end of the document's content. Anything above the document environment is known as the preamble, as we have seen, and usually there is nothing after the end of the document environment. Regarding output file formats, we have already mentioned that LaTeX documents can be output in two different ones, DVI and PDF. DVI, which stands for device independent, is small and fast to create, but it has some limitations. In particular, it supports no font embedding and no interactivity such as hyperlinks. PDF, on the other hand, is bigger than DVI and slower to create, but it supports a lot of additional features. PDF is also the de facto standard for modern documents, and PDF files produced by the PDF LaTeX compiler may need further compression depending on the LaTeX distribution that you use. In order to compile a LaTeX file, we can use either PDF LaTeX and then the file name, which outputs a PDF file, or LaTeX and file name, which outputs a DVI. Please do not specify the file extension when invoking the LaTeX compiler. The compilation process also produces a number of intermediate files with many different extensions, which we will learn to know in future videos. The web is full of useful resources on LaTeX, and in particular you might want to give a look at the not-so-short introduction to LaTeX, which is hosted on C10, the LaTeX Wikibook, which is at the address n.wikibooks.org/wiki/LaTeX, and the Comprehensive Tech Archive, or C10, at the address www.c10.org. Also remember that Google is your friend. Thank you for watching, and if you liked this video and found it useful, please click on the like button.